Hi, welcome back to the channel. This is the video about the Bosch injection system. So this is section 2.5, part 2, let's say. Gauge pressure versus absolute pressure versus vacuum. So I've described engine intake airflow and loads in terms of manifold pressure, and I've discussed the units of measurement used to describe pressure. Now it is important that you understand exactly what you're measuring. For many years, people have traditionally thought about engine airflow and loads in terms of vacuum, the vacuum created in the intake manifold by the piston intake strokes. Using atmospheric pressure as a baseline of 0, the lower manifold pressure is expressed as a negative value, vacuum. By the 1980s, the automotive industry had moved away from thinking in terms of vacuum. Widespread use of fuel injection began to demand more accurate measurements of manifold vacuum and turbocharging, where manifold pressure may exceed atmospheric pressure. And turbocharging, where manifold pressure may exceed atmospheric pressure, began to blur the distinction between vacuum and pressure. A simpler and more useful approach is to think in terms of manifold absolute pressure, MAP. MAP stat refers to the pressure in the intake manifold, which is positive compared to 0 absolute pressure, rather than negative compared to atmospheric pressure. If that seems hard to understand, think of atmospheric pressure at sea level. We tend to think of this as 0 pressure, and in fact, an open fuel pressure gauge will read 0 at fuel level. But remember, atmospheric pressure at sea level is actually 1 bar. Almost all pressure gauges use atmospheric pressure as their reference. Any measurement made with the gauge reads pressure only with respect to atmospheric pressure, as indicated by figure 2.12. A gauge which reads 0 pressure at sea level, atmospheric pressure, is actually measuring 1 bar on the absolute pressures. Oh right, yeah. Oh right, so yeah, the absolute pressure. Oh yeah, so you got here. So when it's zero bar in terms of atmospheric pressure, that's still, oh right, yeah, absolute scale, that's 1 bar then, isn't it? Absolute. Atmospheric scale. Calibration of pressure gauge influences how you interpret pressure readings. Absolute scale. Atmospheric scale. Blimey. Using absolute pressure as a reference point, the piston on its intake stroke is creating a very low pressure in the cylinder, approaching 0 absolute pressure. The pressure in the intake manifold absolute pressure, is higher and always a positive number. Higher still is atmospheric pressure outside the engine. Its influence on manifold pressure controlled by the throttle. Boost from a turbocharger or supercharger is pressure above atmospheric pressure. Many European boost gauges read MAP. They are calibrated from 0 absolute pressure, so with the engine off, the gauge reads 1 bar normal atmospheric pressure. Whoa, this is getting a little bit complicated, isn't it? Oh, blimey. Let's look at this. It's got another little diagram. Sorry about my camera work, it's just... So he's saying he has been driving with a vacuum gauge connected to the intake manifold of each of my last 9 cars. The gauge comes calibrated in terms of vacuum, so at wide open throttle, watt, it reads close to 0. I have also marked my gauges to read MAP, positive manifold pressure relative to absolute pressure at or near sea level. That means that at watt, near 0 vacuum, my gauge reads about 9 on the homemade MAP scale as shown in figure 2.13. Ooh, blimey. Ooh. Oh, blimey. I can read it 2 ways. Multiply by 10 to repressure in kilopascal, 90 kilopascal, or divide by 10 to repressure in bar, 0.9 bar. The important point is that the numbers increase as the load and power increases. Figure 2.4 shows approximate range of gauge values for various driving conditions and throttle positions. By coincidence, 65 mph cruise reads about 65 kpl or 0.65 bar. So he says here, right, manifold vacuum gauge calibrated to read vacuum in inches Hg can also be calibrated to read manifold absolute pressure MAP. Oh, right. With fuel injection or forced induction systems, MAP makes it easier to relate engine load and throttle opening to manifold pressure. That's quite complicated now. Means 0.2 bar or 20 kilopascals. MAP. Oh, so he's put the stickers he's put on there are MAP. Yeah, and the manifold vacuum in inches goes the other way. Wow, I'm gonna have to come back to this. It's quite complicated. I'll do another little video on this section because this is quite hard, isn't it? I'll come back to the next one. So there's one more diagram and we're done. I'll come back to this section and do some more work on it. So I didn't realise it was this complicated, to be honest. So figure 2.14 gauge schematic shows how vacuum and MAP indicators relate to throttle openings. Oh, right. Increasing load this way, clockwise. MAP, kilopascal, equals kilopascal divided by 10 or bar times 10. Kilopascal divided by 10. It's got 2, MAP, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vacuum inches, 24, 21, 18.5, sorry. 24, 21.5, 18.5, 15.5, 12.5, 10, 7, 9. Vacuum into, oh, so overrun. So he's saying it's low pressure, idle. Then the pressure's the MAP is increasing as into cruise. You have increasing load is increasing work. Part throttle acceleration is 8. Somewhere in there, that should say wide open throttle, shouldn't it? Wow. So, figure 2.14 gauge schematic shows how vacuum and MAP indicates relate to throttle opening. On a turbocharged car, boost will read above 10, 100 kpl on the MAP scale. MAP changes continuously from about 20 kilopascal during overrun, coasting with closed throttle to perhaps 160 kp at maximum boost. When we discuss the importance of manifold pressure to fuel injection, you will find it an advantage to think in terms of the positive MAP values from absolute zero rather than vacuum. Right, that was quite complicated, wasn't it? Especially that diagram. This picture, I don't 100% understand. I'm coming back to this in another video, but that was just, this was a section on gauge pressure versus absolute pressure versus vacuum. So I still hope you found it interesting. I'll go through this again. And this is section, this was section 2 in the last part of section 2 in the bush, the engine management fundamentals. Please like and subscribe to the video. Please like the video and subscribe to the channel, and then I'll come back and do some more on this section. Thanks for watching, and I hope you enjoyed it still, and might have made a bit more sense when I go over it as well. But it's still been useful to understand like absolute scale and atmospheric scale of pressure, and gauge pressure versus absolute pressure versus vacuum. So see you in the next video. Thanks.